Good afternoon all. Myself Dr. Arun Kundi, Associate Professor and HOD CSE Department. Today I am going to discuss about the concepts of the data structure and its applications. So, the very first one is the data structure. So, data structure is a method of arranging data in the memory. Either you can store a data or retrieve data, you need a method. For that one, we make use of a concept of a data structures, where it facilitates a storage, retrieval and searching of a data from the memory. So, for in this data structure, n number of techniques are there. Among that, we are going to highlight the few of the techniques, such as stacks, queues, linked list, trees, and finally the graphs concepts. These are the major concepts we are going to discuss related to the data structures. Among these, we are going to highlight the concepts of or techniques behind the stacks. The stacks. The very first one is the stacks. Stack is a data structure which facilitates a storage of a data in the memory, in which we can add an element and or we can delete an element through the same end card as a top end. We make use of here top end for insertion and deletion of a element. Deletion of element. Deletion of an element. So here through the top end, and here this the stack is going to make use of a concept of the LIFO. The LIFO is nothing but last in first out. The element which is inserted last will be popped first. The real-time examples of these stacks are wearing of bangles. Wearing of bangles. So the wearing of the bangles, if you add means if you going to wear the last bangle, it should be removed first. This is a concept behind the stack. It means that the last bangle which is added or inserted will be popped or removed first. This is a real-time example of a stack. At the same time, another example is arrangement of plates. So where the plates which is inserted which is placed or last will be popped first. These are some real-time examples of the stacks. So again after that one, again in these stacks, there are three different type of operations are associated with the stack. First one is push operation, second one is pop operation, and finally display operation. So here in this push, pop and display, we are going to just discuss about the concept of the push operations. The push operation is one in which the elements are inserted into the stack by making use of a top end. Assume that there is we are going to define a stack size of 5, and I want to add an element into the stack. The stacks are implemented using the arrays. Just see, this one is an example of the stacks where when the stack is empty, top points to the -1 and these are the respective locations. Since the stack size is 5, so maximum location is 4. The starting location is 0 and -1 is used to represent the stack is empty. So we need to check for the two condition here. One is for a stack empty and another is for a stack full. So stack empty condition. The stack empty condition is checked against using the condition if top equal to, if the top equal to -1, if the stack is pointing to the last value, means the -1 value, then the stack is empty, no elements are there in the stack. So you can display it by using these conditions. If the stack is full, again we need to check for this. Assume that I want to add an element into the stack. So 10, 20, 30, 40 and the 50. We are now going to do it then the top is incremented every time and it's going to point to the last value. That is, top is pointing to the fourth location. For this one, to check this condition, if the stack is full, how going to check it? Stack full condition, stack full by using if top is pointing to the last location in the stack. That is, stack size -1, then you can tell that stack is full. If the top is pointing to the last location, the stack is full. The major applications of the, so just I want to discuss just the push operation here, how the stack is, how you going to need add an element into the stack. So assume that this is a empty stack, 0, 1, 2, 3 and the 4, and the top is pointing to the -1 value. If the top is pointing to the -1 value, the stack is empty. Now for this one, how you going to write a code for that one? Why push the function for that one? So I need to take a in top and you need to check against that one. For adding an element into the stack, we need to check for the full condition. So if the stack is full, it is not possible to add an element. So we want to check for the stack full condition here. If the stack is full, it will not allow the element, the stack will not allow the elements to be added. If the stack is empty, it means that it's facilitated adding some more elements, then we have to, since the top is pointing to the -1, you need to upgrade the top to the 0th location. To upgrade the top to the 0th location, you have to increment the top by 1 value. So it means the top equal to top plus 1. That is what? -1 plus 1. That is, the top value becomes 0. Hence the top is pointing to the 0. Now you can fill the elements by using the stack. That is, S of top equal to item. So this is how the elements can be inserted into the stack using the arrays concepts. At the same time, we can make use of a pop function to delete an element from. To delete an element from the stack, we make use of a function called the pop, and again we need to make use of a top as a reference value. Again, before deleting an element of the stack, we have to check for the stack empty condition. If the elements are not there in the stack, it is impossible to delete. That's why you need to check for the stack empty condition initially. Once you check for the stack empty condition, if the elements are there, then you can delete an element from the stack by using the top value. That is, copy the value pointed by the top into the item and display the same. The element which is deleted is item, which stores the deleted elements. Once you delete this one, you have to, for example, 10, 20, 30, 40. These are the elements are there. When the top is pointing to the 40 or the third location, when you need to delete a 40, you need to move to the next location. That is 2. This is done by decrementing the top by 1. That is, top equal to top minus 1. So this is how the insertion of an element and deletion of an element from the stack is done, and we call that one as a push and the pop operation. At the same time, we can make use of a display operation to display the elements of the stack from either in a same manner in which they are entered or in the reverse fashion in which they are entered. So under the display function. So the major applications of the stack are, the main application of the stack are, here we make use it for recursion functions, and another one is for evaluation of a postfix expression or conversion of a infix to postfix expressions. So before that, the recursion is nothing but the difference between the recursion and the iteration is that recursion is nothing but where till the condition, particular condition holds true, the loop will execute multiple times or infinite times till the condition holds true. It does not have any limit. It may be 1, 2, 3 or n number. So in the recursion, again it may make use of these concepts for solving such as Tower of Hanoi problems, any GCD and LCM of a number, any kind of a numbers which involves a recursive functions. In the evaluation of a postfix expression and also the conversion of a infix to prefix or postfix expression, we make use of a stacks. And also while reading a printf, while displaying the printf and a scanf content, again we make use of a stacks in a C programs. So these are the major applications areas of the stacks. So these are all the content regarding the one of the data structure, that is stack, and its functions and its applications. Thank you for providing an opportunity for attending this Namana series. I thank all the people who supported me and guided me. Thank you.